Sometimes, late in an epidemiologic study, you discover subjects who should have been excluded from the study population. You don't have the resources to scrutinize the records of everyone, so what do? Our paper presents algebra and examples to show when you should remove those late discovered ineligible outcome cases. Two of us had been involved in a large cohort study on mortality from hepatocellular carcinoma. A post-hoc exclusion rule seemed intuitively obvious. We had used medical record codes to screen out HCC at baseline. Even so, when we identified the eventual HCC deaths and went back to their written medical records, we found a few with liver cancer already at cohort entry, even though it had not been coded. We took those people out of the study. The formal concern is that the textual review of caregivers' notes happened only for persons who died of HCC, and not for the whole population. Were we biasing the study with selective review? Here are numbers drawn from the motivating example of HCC. We walked through all the study parameters and wrote down their algebraic connection to the study result. We considered the sensitivity and the specificity of the population-level exclusion criteria. We looked at the risk of outcome, the relative risk associated with treatment, and the relative risk associated with the condition to be excluded. You can see here that we've postulated no effect of the test treatment, so that any relative risk at the end of the study is a measure of bias. We've also followed the HCC study in setting a very high relative risk for HCC death associated with HCC itself noted at baseline. First, we looked at population and case counts in the absence of early screening or late exclusions. The crude relative risk of 1.96 indicates substantial confounding. The confounding is essentially gone after selective removal of the ineligible cases that were discovered late in the study. We explored this effect for a variety of scenarios, some of them much less extreme than the HCC study. In every case in which there was preliminary screening of the population, followed by late exclusion of ineligible outcome cases, confounding disappeared almost completely. Even without population screening, exclusion of ineligible cases almost always reduced confounding. Our conclusion is that researchers should remove ineligible outcome cases from their studies, even when the ineligibles are discovered by techniques that cannot be applied in the full population. Thank you.